Okay, in this video, I'm going to explain trigonometric function values of coterminal angles. So let's review the concept of coterminal angles. So two angles are called coterminal if they share the same terminal side. So for instance, let's think about two angles, say 50 degrees and let's say 410 degrees. So if you draw these two angles, here is 50 degrees, and 410 degrees is 360 plus 50 degrees. So 360 degrees, it tells you to go around the circle once, and then plus 50 degrees more. So if you look at these two angles, they share the same terminal side. They basically end up at the same place, right? So these two angles are coterminal. In fact, there are more coterminal angles. So for instance, if you go out one more time, so 410 plus 360 more, you're going to get 410 plus 360, 770 degrees. So this is another coterminal angle. If you go backward, you end up with negative 310 degrees. 50 degrees short from 360 degrees, but in the negative direction. So negative 310 degrees. So if you add or subtract 360 degrees once, twice, or three times, as many times as you want, you will always end up with the same place, and that's going to produce coterminal angles. Okay, now I want to talk about trig values of coterminal angles. So let's review the definitions of sine, cosine, and tangent. So when you draw an angle theta, it could be any angle. Let's suppose theta looks like this. Then sine theta is, you just pick a point on the terminal side of the angle and measure the distance between the origin and the point, and we call it r. The formula relating the r value and xy values is this. And sine theta is defined to be y over r, cosine theta is x over r, and tangent theta is y over x. So that's the sine, cosine, and tangent values of theta. Now let's suppose we have a coterminal angle. Let's suppose there is another angle that ends up in the same place. For instance, let's say theta plus, say, 360 degrees. Now theta plus 360 degrees, it has the same point on the terminal side and the same value r. So if you compute the sine, cosine, and tangent of this other angle, we will have the same values. It's the same values of sine, cosine, and tangent. Or if we have another angle, say, that goes in the negative direction, theta minus 360 degrees, well, it'll end up at the same place. So again, the same x, y, r values, so it'll give you the same sine, cosine, and tangent values. So the bottom line is that the coterminal angles will always give you the same trig values. Okay, let's take a look at a couple of examples. Find the exact values of sine 1485 degrees and cosine of negative 330 degrees. So 1485 degrees. If you divide this by 360 degrees, let's bring up a calculator. It's a little bit more than 4, so 360 degrees goes into this number 4 times. And 4 times 360 is 1,440. And if you subtract these numbers, we get 45. So it means that the 360 degrees goes into this number 4 times and 45 remains. So we can draw this angle in this way. So 4 cycles, 1, 2, 3, and 4, and then 45 degrees more. This is 1,485 degrees, and it is coterminal to 45 degrees. So from the theory we learned just ago, it means the sine of this angle is equal to sine of the coterminal angle, 45 degrees. So we just simplify the angle. And 45 degrees is one of the special angles, and sine value of this angle is, as you know, square root of 2 over 2. Let's look at the second example. You can get a coterminal angle by adding 360 degrees, and it's going to give you 30 degrees. So if you draw this negative angle, it'll end up with the same place as 30 degrees. So if you measure it positive way, it's 30 degrees. If you go around the negative direction, it is negative 330 degrees. So cosine of this negative angle equals cosine of 30 degrees, which is, as you know, square root of 3 over 2. So the idea is if you're given a really big angle or some negative angles, you can just add or subtract or maybe divide to get some simpler coterminal angles and use them to compute the trigonometric function values.